In the name of God. Hello, dear students. Welcome back to Ferho's website. My name is Masoud. I'm a physics teacher. We are here to explain physics curriculum. Our goal is to make the physics easier for you as much as possible. In previous lesson, I explained centripetal force. We said that centripetal force is a force that maintains circular motion. Centripetal force is a source of centripetal acceleration. And these questions actually, I prepared it for you. These questions have to do with centripetal force, right? But I'm gonna add one more note for you before I start, let's say, answering these questions. I'm gonna add one more note for you, and I'm gonna jog your memory about the information that I talked about in previous lesson, right? For example, imagine there's a car, all right? There's a car. The car circles the square. This is a square, right? It's a circular track, and there's a car. This car circles the square. So it has a centripetal force. Centripetal force, let's say, urges the car to pick up centripetal acceleration. So centripetal force is a source of centripetal acceleration. I can say this arrow, the green arrow, is FC and AC simultaneously. What does it mean? It means FC is parallel to AC. Between any two parallel vectors, actually there's a zero angle. So theta, the angle between these vectors, the angle between centripetal force and centripetal acceleration is zero, right? Because between any two parallel lines, there's a zero angle between them. So this is the, let's say, background of view. I explained this, except for this angle. I didn't mention zero angle, actually. I explained FC is parallel to AC, but right now I'm gonna add one more note for you. I had to explain it in previous lesson, but right now I'm gonna add it before I solve these problems, these questions. Beside the centripetal force and centripetal acceleration, because the car circles the square, circles the circular track, that's why this car has a tangential velocity as well, Vt, right? Let's say, assume that the car moves with a constant speed. What does it mean? It means tangential acceleration is zero, for example. But Vt, actually, Vt is constant. There's Vt. I want you to determine the angle between Vt and Fc. And this is one of the questions of national exam of previous years. So what's the angle between, I want you to determine the angle between Fc and Vt. And which type of relationship is there between centripetal force and tangential velocity, tangential speed? I'm sure you know the answer. I can say Fc, let's say, is perpendicular to Vt, right? Fc is perpendicular. Let me write it again. This one Fc and this one Vt. I can say Fc is perpendicular to Vt. It's clear from the figure, right? The angle between them is a right angle. What does it mean? It means theta is equal to 90 degrees. Theta is equal to 90 degrees between, let's say, centripetal force and tangential velocity. Keep in mind that if the quantities are similar, like centripetal acceleration, centripetal force, right? So the angle between them is zero if the quantities are similar. But if the quantities are different, like what? Like centripetal force, tangential velocity. Let's say, so here theta becomes 90 degrees because they cut one another, right? Let me check your information. I'm gonna, let's say, I'm gonna ask you a question and I don't reveal the answer. I want you to go over it. right? Go over this question. I say, what's the angle? How much is the angle theta between, let's say, tangential velocity and tangential acceleration, right? Quantities are similar. Determine the angle between tangential velocity and tangential acceleration. I'm sure you know the answer. I'm not, let's say, gonna reveal the answer, but I told you a note. I said, whenever you hear the word, whenever you confront the quantities with similar name, actually, there's a zero angle between them, right? Right now, I'm gonna I'm gonna answer question number 1. These questions I told you are related to centripetal force. Question number 1, which of the following statements describes centripetal force, right? Let me read it. So they are definition of centripetal force. Let's say we want to make sure which, let's say, definition is right or which one is wrong. Let's say the first one, A, the net force on an object directed toward the center of the object's circular path. The net force, you see, it mentions the net force. What does it mean? What's the meaning of this, let's say, word, the net force? It has a meaning in physics. If you are smart in physics, if you are good at physics, actually, you can, let's say, you can guess the meaning of net. Net force means there are more than one force, right? So if I say the net force on an object directed toward the center of object's circular path, means centripetal force can be more than one force. And mostly centripetal force consists of more than one force, right? The meaning of net is it means there is more than one force, let's say for centripetal force. So it's true, right? It's true. It's a summation of forces, actually vector summation of forces. It's called centripetal force. B, the force that maintains circular motion. It's a very simple definition, and it's a nice definition. We accept it, no problem. So till now, A and B are true. C, the resultant effective force. Resultant means net. It has the same meaning. Resultant force, net force means, let's say, there's more than one force, right? There's more than one force for creating centripetal force. The resultant effective force on a body that moves in a circular track and is directed toward the center of the circular path. So both, let's say, all of these definitions are true. That's why I'm going to circle D, all of the above. All of the options are true. Number 2, it provides the straight line path. You see, I highlighted it for, let's say, for focusing on this. I'm going to focus. I want you to focus on this, let's say, straight line path. That's why I highlighted it, actually. For a ball tied to a string being whirled in a circular track. So this is the ball, and I'm gonna whirl it actually in a circular track, right? In this situation, it says it provides the straight line path. What thing provides the straight line path? I give you two options, right? Either we have inertia of the ball. Does inertia of the ball, let's say, do this action actually? Does it provide the straight line path for the ball? Or centripetal force of a string is in charge of, let's say, is in charge of giving the ball a straight line path. So which one? I'm sure you know the answer, and the answer is inertia, right? Inertia of the ball is in charge of giving the ball, let's say, a straight line path. Question number 3, it provides the circular path, right? It provides the circular path for a ball, for this ball being whirled in a circular track, right? In in a circular track. So I highlighted it actually again for you, circular path. I told you in previous lesson, I told you two factors are, let's say, vie with one another. Two factors are vied with one another. They are competed with one another. What are these factors? They compete with one another. Sometimes one factor overcomes the other. Sometimes the other one overcomes the first one. What are these factors? Centripetal force versus inertia, right? So if centripetal force wins the battle, and if centripetal force overcomes the inertia, the ball keeps moving in a circular track, right? If the inertia of the ball overcomes the friction, overcomes the centripetal force, if inertia overcomes in this situation, ball does not follow a circular track anymore. It flies off actually, and it flies off from the circular track, and it follows a straight line path. That's why I'm sure you know the answer. Which factor provides a circular track for this ball? Is inertia of the ball or centripetal force of the string? Of course, centripetal force of a string is a true answer. Let's move on to question number 4. Centripetal force causes a change in the what? In the space of velocity. Either let's say, actually I'm reading the question, right? I'm gonna focus on this question. Centripetal force is a nice question. We got a lot of information from this question. It says centripetal force causes a change in the what? In the gap of velocity. Is centripetal force is in charge of changing the magnitude of velocity or direction of velocity? Keep in mind that centripetal force does not change the magnitude of velocity, only changes the direction of velocity. So the only responsibility for centripetal force is to change the direction. That's it. Centripetal force never changes the magnitude of velocity. That's why which option is true? I'm sure you know the answer. So direction of velocity is changed by means of centripetal force, not magnitude of velocity. Right? Number 5, let me read number 5 for you. Question number 5. The force that maintains circular motion, Fc, right, acts at right angle to the object's motion. And object's motion, let me add one more note for you. Object's motion means whenever you hear the word motion in this chapter, especially in this chapter and let's say in the next chapter, chapter 1 and 2, a motion here, let's say, means VT, tangential velocity, right? Keep in mind that object's motion means linear velocity, means tangential velocity. So the force that maintains circular motion means Fc, right? Fc acts at right angle to the Vt. Is it right? Of course it's right. I told you, because the factors are different, because the quantities are different, they are not similar. That's why there exists 90-degree between them. So it's true. Right angle means 90 degree. B, changes the direction of object's velocity. It's true. Fc changes the direction. We explained it in previous question. C, both previous options are correct. Of course, we accept these options, but don't hurry. I want you to be careful. I want you to be calm, and let's say I suggest you to read all options. So right now I'm sure C is true, but I don't hurry. I'm gonna read the last one, then I decide, right? D, changes, it's a Fc. Fc changes the magnitude of object's velocity, so it doesn't happen. It's impossible force of a centripetal force does not change the magnitude of velocity. So which option is true? This option is true. Number 6, the angle between tangential speed means Vt, right? Tangential speed and centripetal force. The angle between tangential speed means Vt and centripetal force. Centripetal force means Fc. The angle between them, and by the way, this is a question of national exam. Let me give you a key for answering this question, right? And I told you at the beginning of this lesson, I told you whenever you confront the different factors or different quantities like Fc and Vt, keep in mind that the angle is the right angle. It's not, let's say, zero angle. It's not 0 degree, right? But if you encounter the similar quantities without thinking, the angle is 0. So right now, quantities are different. Tangential speed versus centripetal force. So the angle is 90 degree, right? This is the question of national exam. One more question of national exam, question number 7. One of the following equations is not, look here. One of the following is not true to find centripetal force. So one equation is wrong. Find the wrong equation here. Let's read the option actually. A, Fc is equal to m squared r. Fc is m squared. It's a little bit strange, right? It doesn't make sense actually. It's not reasonable. We haven't encountered this rule in previous lesson actually. But I told you, don't hurry. I want you to read all options. B, Fc is equal to mac. It's true. It's Newton's second law of motion. C, Fc is equal to m omega squared r. It's true, right? Mr omega squared or m omega squared r is true. The last one, D, Fc is equal to m Vt squared over r. And this one is true as well. So it says one of the equation is not true. So we look for the wrong equation, which is the A. So A is true. A is the answer. Actually, A is the answer of our question. A is the answer of question number 7. Let's move on to another question, which is question number 8. Let me read the question number 8. Right? What's the angle? And by the way, this is the question of national exam as well. What's the angle between centripetal force and, let me show it to you for better vision actually. Let me pull it down. What's the angle between centripetal force, Fc, and centripetal acceleration? Fc, AC, right? Are quantities similar or not? If quantities are similar, without thinking, the angle is 0, right? So here there are some options. The options are 90 degree, 45 degree, 0 degree, 180 degrees. So the answer is 0 degree because, the angle is 0 because the options are similar, because the quantities are similar. Number 9, this is the question of preliminary exam. You see, there are a lot of questions in national exam and preliminary exam that concentrate on the angle between Fc and AC, angle between Fc and Vt. So, and I gave you a key for, let's say, for finding the answer in a split second. 9, what's the angle between centripetal acceleration, means AC, right? Angle between AC and what? AC and tangential acceleration and AT. AC and AT. They are not similar. So the angle is 90 degrees because centripetal versus tangential means they cut one another. They make a right angle between each other. That's why the angle will be 90 degrees. Question number 10. A ball is attached to a string and whirled in a vertical circular path. Right now, we tied the ball actually. We tied the ball with a string and we whirl it in a, let's say, vertical string, in a vertical track, not horizontal, vertical, right? In a vertical, like let's say I showed it to you in a figure. It says a ball is attached to a string and whirled in a vertical circular path as shown in the figure, like this, right? What happens if the string breaks? Breaks especially at this position. When it reaches here and the, let's say, and the string breaks, what happens to the ball, right? What happens to the motion of the ball if the string breaks, especially at this position here? When ball reaches here and actually the string breaks. Let me read the option. The first one, A. The ball moves vertically upward in a free fall. So the ball moves vertically upward in a free fall. It can be. B. FC vanishes. Vanishes means disappears. FC, let's say, is no longer remained. FC, let's say, disappears. FC becomes zero, right? It's true, because here in this situation, when the string breaks, there is no FC anymore, and the inertia of the ball overcomes this situation. That's why it moves upward in a tangential velocity, right? By tangential velocity, it moves upward. See, the ball does not move in a circular path. Of course, the ball does not move in a circular path. It follows a straight line path. All of the above. So we accept all of these information and we circle D, which is all of the above. So all of the options are true for this situation, because whenever the string breaks, FC becomes zero. When FC becomes zero, inertia of the ball, let's say, controls the situation and gives the ball tangential velocity and moves it upward, let's say, in a straight path, and it does not move the circular track anymore, right? So this is the first, let's say, this equation, this question talks about this phenomenon. We actually we discussed it. We discussed it. Let me read another question for you. It's similar for this question, but the last question for this lecture, actually. Let me read it for you. Question 11. A ball is attached to a string and whirled. We circle it, right? And whirled in a vertical circular path, as shown in the figure. Right. What happens if the string breaks? What happens if the string breaks, especially at this position, especially here, when the object reaches the, let's say, top of the path, top of the circular path? It reaches here and suddenly a string breaks, right? So firstly, when the string breaks, FC vanishes, FC becomes zero. And when FC becomes zero, what thing overcomes the situation? Actually, inertia of the ball overcomes the situation. Let me read the option for you. It says, A, the ball will fly off, right? The ball will fly off horizontally in a direction tangent to the circular path. In the situation when the ball reaches the top of its path and the string breaks, in this situation, the ball flies off actually horizontally. It flies off by means of what? By means of tangential velocity. It picks up tangential velocity, and inertia overcomes the friction. Inertia overcomes the tension, and after that, actually, it follows a parabolic path, right? The ball cannot, let's say, move in a horizontal, in a perfect horizontal path because of friction between air particles and the ball. So it slows down. It slows down and it follows a let's say it follows a parabolic path rather than a straight line path. So this is the first one. The ball flies off horizontally in a direction tangent to the circular path. It's true, we accept it. B, Fc vanishes, of course. Fc vanishes because a string breaks. C, the ball will follow a parabolic. You know what parabolic path? Parabolic means like projectile. Parabolic path of projectile, it's true. And all of the above is true, right? That's all, guys, for today. Thank you very much for watching this video, and bye for now.